So we're going to continue talking about atherosclerosis. However, we are going to extend the topic to lipoproteins. The formation of atherosclerosis is caused by these factors. We have inflammatory components. There is lipoproteins involved, macrophages. You also have endothelial cells and vascular smooth muscle cells, which we talked about previously. Now, let's begin with lipoproteins. What are lipoproteins? Lipoproteins are simply the combination of a lipid molecule with a protein molecule. So we have lipoproteins in our body have the function of carrying lipids from the body and supply it or carry it back. The types of lipoprotein molecules are chylomicrons. We have chylomicrons, we have VLDLs, IDLs, LDLs, and HDLs. The first categorization is on the delivery. All of the the first four that I mentioned carry lipids from the liver or the intestines to the body. So therefore they're providing lipids to the cells. And whereas the HDL is the only molecule in the body which carries lipids from the cells or from the vessels from the cells to and brings it back to the liver. The second categorization comes for the first four lipids that we talked about. Chylomicrons are the only lipoproteins which carry lipids towards the cell from the diet. Therefore, whatever you eat is uptaken by the chylomicrons and they carry it to the cells. Via the other three lipoproteins, the VLDL, IDL, and LDL, are the lipoproteins which carry lipids from the liver and they bring it to the cells. The third categorization is on the basis of the apoproteins attached to the lipoproteins. The lipoprotein molecule contains these apoproteins, which are receptors, which are like receptors, which help in signaling and letting go of the lipids that are being carried. Chylomicrons are the only lipoproteins that contain the apoprotein B48, whereas the other lipoproteins contain the apoprotein C2. Alright, so the exogenous method of lipid transport is through chylomicrons after a meal. Chylomicrons carry the lipids from the intestines and they interact with the surface of the cells that require the triacylglycerols, where the ApoC2 molecule interacts with the lipases to allow the release of triacylglycerols by hydrolysis. For the exogenous method, which doesn't involve the chylomicrons, the liver is responsible for producing the VLDLs, which are molecules high in triacylglycerols, whereas their cholesterol content is comparatively lower. They also contain the ApoC2 protein, which interacts with the lipase enzyme to allow for the release of the triacylglycerols for the cell uptake and converting the remaining lipoprotein molecule from the VLDL into IDL. And as the lipoprotein molecule travels through the bloodstream, it keeps on releasing the triacylglycerols. The cholesterol content comparatively to the triacylglycerol content increases, and we have the formation of IDLs and ultimately LDLs. IDLs are usually going to be resynthesized in the liver to form VLDLs again. However, a small amount of the IDLs will be converted into LDLs, which are responsible for cholesterol delivery to the tissues. The cholesterol uptake is regulated by the LDL receptors, which are responsible for controlling how the cells uptake cholesterol and to what extent. Unlike the LDLs, we have the HDLs, which perform a reverse transport of the cholesterol from the cells, which carry excess cholesterol from the cells back to the liver. This involves using the ABCA1 transporter. HDLs uptake cholesterol through esterification of the cholesterol esters using the LCAT enzyme, and it moves the esterified cholesterol esters back into the HDL for transporting it back to the liver. It is also possible for the HDLs to transfer these cholesterol esters to the VLDLs for transport.